Hello, and welcome to Oliver's webinar, 5 Packaging Misconceptions, Right-Sizing Your Medical Device Packaging. I'm Haley Schraben, Product Manager for Oliver Healthcare Packaging, and I'll be your moderator today. We've got just a few brief announcements before we begin. First, this webinar is designed to be interactive. So in the bottom right of your screen, you'll have the opportunity to click chat or Q&A. If you're experiencing technical problems, please use the chat function and we'll do our best to assist you. You can then use the Q&A function to ask questions that relate to the content of the presentation. And you can check a box to make sure your question is asked anonymously if you prefer. So again, if you're experiencing technical problems, use the chat function. And if you've got a question that you'd like to submit to the presenters to address at the end of the presentation, you can use the Q&A function. And now on to the presentation. Today's agenda will include 3 topics. First, we'll review what it means to right-size your medical device packaging, including why it matters and various design solutions to consider. We'll then dive into some common packaging misconceptions and provide clarity for each of them. And finally, we will review case studies that explain the benefits of HDPE backer, or AKA mounting cards, and right-sizing your packaging. Discussing today's topic are Jeremy Elwell and Kevin Fisher, both technical managers at Oliver Healthcare Packaging. Jeremy is a graduate of the Michigan State University School of Packaging with several years of experience as both a packaging manager at medical device manufacturing organizations, and he brings the expertise to Oliver to support medical device manufacturers. Kevin has been supporting both startup and more established medical device companies in the healthcare packaging space for over 13 years, and he has extensive knowledge and experience with packaging design. So first, let's kick things off with a poll question. Do you currently or have you ever worked with sterile barrier system designs? Yes or no? And we'll give everybody about 10 seconds or so to submit an answer. Excellent. So most of the participants on the call have worked with sterile barrier system designs. So this will be familiar vernacular for you all and a really excellent overview. It's nice to have a baseline to know who's familiar here. And for those of you that aren't, this is going to be a really great introduction into some things to consider. So Jeremy, with that, I'll hand it over to you.
Thank you, Haley, and thank you everyone for joining. I'm Jeremy Elwell, and it's a pleasure to be here today. I will be joined by Kevin Fisher shortly, but first I'm going to go through a little bit of an introduction here to right-sizing your packaging and why it matters. So as most of you know, packaging designs and packaging systems can go through a lot of stresses as we go through the testing process and development. And that stress can occur during manufacturing, transportation, and handling. And really, if you don't size your packaging correctly, those defects, those risks can be amplified. So throughout this presentation, we'll review why right sizing is ideal and solutions to implement into your design to mitigate associated risks. So the reason why we thought this was a very pertinent topic to talk about is we do see trends around the industry where organizations commonly use existing sterile barrier systems for new products. So going through a line extension or a new product development project, you could make a quicker route by using a packaging design that already exists and packaging components that exist in an organization. However, before this should be implemented, all of the risks should be analyzed and looked at before testing begins, because there are associated risks, and we'll go through those in these next slides. We'll show some potential risks that can happen with an undersized pouch system. So this is an example of a product with a very tight fit inside of a pouch. And these 6 potential defects are really just 6 that we are talking about today. There could be other defects or other potential concerns with a packaging design, but here are 6 very common attributes or very common defects that can happen. So the first we'll review is seal creep. In the upper left-hand corner, this is an example of what seal creep may look like during die penetration. So seal creep in a pouch system like this can occur with the product fit alone. So if the product is tightly fit into the pouch, it could press against the seal or separate that seal to where the seal could creep partially through the seal area or even through the entire seal area itself. And this product fit combined with the stresses of shipping or the sterilization process could amplify this issue. Pressure changes in vacuum cycles can contribute to this severity. For example, in EO sterilization, higher elevated heat plus a vacuum cycle, many pulses of a vacuum could occur to where all of these contributing factors could cause the seal creep. So that is the first one. And then furthermore, in wrinkles and channels in the seal, this is an example of the wrinkles that could occur during a sealing process. So while this is mainly a manufacturing focused area when you're doing part of your sealing process, this should also be considered during your packaging design process. You need to keep enough room on your pouch at the end of the pouch to have a flat area in order to have that flat seal area inside the pouch machine, inside the sealer, in order to make sure that there's no wrinkles. These wrinkles can lead to channels, which can lead to a sterile barrier breach. Next is probably the most commonly diagnosed type of defect, and that is a puncture defect. And when somebody or an organization sees a defect, sometimes this is what they think of first. There's a hole in our pouch. This happened during distribution. It must have been something puncturing through. So this can occur with the device inside of the pouch from the internal forces or from external forces from something from the outside poking in. So this diagnosis of a hole is from puncture, while it can be common, it's not always the only contributing factor or cause of a pinhole. Another area of concern could be flex cracking. And flex cracking is when an area of film or any other flexible material has the opportunity to flex in a pointed area many times to where it causes stress marks on the film, and which can also eventually lead to a pinhole. So the difference between these two, really on a microscopic level, you can see that there's witness marks around the flex crack, while puncture, there might be protruding material. And it's really important to look at these closely before diagnosing the cause. Another type of pinhole that can occur is from abrasion. So abrasion is typically scratches on a film surface that can occur when that film is rubbing up against the device inside, or a protective packaging system component, like a shipping container or a shelf carton, typically during the vibration cycle of distribution testing. So again, this one could also lead to a pinhole. And these three in the middle are all different defects, all different causes, but could look the same within a test method depending on how you're looking at the defect itself. Also, Tyvek tenting can occur if you're using a undersized pouch, a tightly fit product, and that Tyvek tenting can perform the same as the film side of the pouch, could cause a peak to occur, and could have the same type of defects with flex cracking and abrasion that can also lead to a hole as shown in the picture in the Tyvek area here. Now, Tyvek is widely used in pouch applications and offers great protection attributes, but it also can be a little bit stiffer than other flexible packaging types within a pouch system. So this area of tenting can be even more severe than a pouch. And so it's important to look out for this, but also another defect that can occur will be from Tyvek sheet separation, which is when the Tyvek itself is manipulated enough where the inner layers of the Tyvek could start to separate with repeated flexing or manipulation. So there are industry white papers out there that explain this phenomenon more in depth. And Kevin, we have one more defect. Can you walk us through this one, please?
Sure can. Device protection. So Jeremy showed things that can happen to the sterile barrier, but we can't forget that the device needs to land with the end user intact and functional. So can the device kink easily? Does it have a coating? Can it coil? If so, how tight without taking a set? these are always good to know. It's always good to know the parameters of your device because you can only design for what you know.
All right, let's move on with another poll question. Which type of solution is most impactful to the success of the sterile barrier system? Is it size, materials, package type, or all of the above? And again, we'll give about 10 seconds to answer. All right, so a majority of the participants answered all of the above, which is correct. So as we move on here, Jeremy and Kevin are going to walk through all of these, how they impact the sterile barrier system and what to consider to succeed in keeping your product and package safe.
Thanks, Haley, and thanks everybody for answering that. It was a pretty simple type question. Any of those answers would have been pertinent, and there are other answers as well that could lead to the success of a packaging design system. We would like to review those 3 plus 5 total here about what types of solutions can you put into your packaging design to avoid or mitigate those defects that we just went through. And mainly we'll be focusing on pouches, but we'll also go into different types of packaging as we go along. But first, quite an obvious one after we talked about right sizing your packaging is to change the pouch size and or style. So increasing or decreasing pouch size could help mitigate the risks that we've discussed. In the example we had, increasing the pouch parameters really would correct most of those issues, but if you increase too far, you may also introduce new defects. So it's important to right size, not only go too big, but also to just make sure that everything is working together as you look at your pouch system, whether you have a single or double sterile barrier, plus protective packaging, and how they all work together. You really want to focus on that. We'll start to focus on those aspects of the packaging design in further slides in this presentation. In addition to size, style, pouch style is very important as well. On the right side of the slide we have 3 different styles of pouches for medical device packaging. The first is a chevron style, and this is probably the most popular style out there. So this is based on the shape of the seal trace, where it's the shape of a chevron, and this allows for ease of opening as well as handling and aseptic presentation for the end user. This is typically an peelable style pouch and is, like I mentioned before, the most common. However, there are also corner peel pouches, which are the same type of opening mechanism, being a peel, where the seal is a peelable, has peelable attributes. But in this case, there's only a small portion on the corner that is the peelable section where you start the peel. So the advantage of this style is that with the corner peel, you have more of a flat and straight seal area at the end, and it will give you more area within the package for your package device. With that same shape, we have a square cut pouch. So this will offer even more room because of the square shape of the seal trace. But in this situation, there are no, this is not a peelable pouch for most of the time. It's a tear open. So there's 2 tear notches, one on either side, and you would tear open this pouch by removing the top of it. So it's important to look at these from your package fit, but also from the end user and how this will be presented into the sterile field. Each one of these has their advantages, but also you want to be concerned about, is the device inside able to be handled based on the style of pouch that you are designing. And finally, on this slide, right sizing your sterile barrier system can reduce the amount of protective packaging needed. So it's very common in my experience that I've seen a lot of protective packaging being used if, for example, an existing pouch design is used for a new product. Maybe to mitigate risk, you can use a divider within a carton or a shipper, or use of bubble wrap or air pockets to cushion the product inside. So while this is a good way to protect your packaging system, your sterile barrier system, it also does add cost and material. So instead of going that route, it might make sense to really focus on the size and the style of your packaging design up front in the design process. Next, we'll talk a little bit about choosing the appropriate material. So going back to the puncture defect that we discussed in the first section of this presentation, that puncture for this situation is occurring from a molded part of this device, and for the scenario poking through the film side of the pouch. So when selecting and designing your packaging system, you want to really make sure you understand the properties of the film side and also the Tyvek side of your pouch. In this example, we're showing a graph of puncture resistance on the bottom of this slide, where this graph is showing 48 gauge polyester based film and a 92 gauge polyester based film and 200 gauge biaxially oriented nylon based films. And as you can see, these are listed in pounds force. This is the amount of puncture resistance that each film provides. So the polyester, 48 gauge polyester, is about 5 to 6 pounds resistance. And when you double that, you're getting about double the protection to 9 to 12 pounds resistance. But if you switch to a nylon-based pouch system, you can get up to 13 to 14, 15 to 17, depending on the structure. These are just typical values, but the trend line is important. Going from polyester, going to a thicker version of that offers more puncture resistance. Then going to that nylon-based film offers even more. In addition to that, choosing the appropriate material combination is important. So in this situation, we're going to go back to the seal creep aspects of the defects we talked about. And when considering your seal, you want to consider the sealing process, but you also want to consider the sterilization modalities used as well as distribution channels. Whether it's going to be shipped through the mountains at a high altitude, on a ship, on a plane, you want to consider what it's going to see so you can plan appropriately with your seal strengths and your material combinations. So focusing more on sterilization modalities, on the bottom, we have two graphs. On the left side is that 48 gauge polyester and 2 mil low density polyethylene film sealed to uncoated 1073B Tyvek. This is showing a seal curve at different temperatures, 240 Fahrenheit to 270 Fahrenheit, and the associated peel strength values from 1 pound all the way up to over 2 pounds of force, pounds per inch. So this is a very typical, very widely used material combination, but it's not appropriate for every sterilization modality out there. It is compatible with ethylene oxide and other gas sterilizations, as well as gamma radiation and other types like X-ray and E-beam. But for steam sterilization, this is the example we're showing here. On the right side, this is a high-density polyethylene-based film sealed to that same uncoated 1073B Tyvek. And if you can see the difference there at the bottom, we have a higher sealing temperature from 320 degrees Fahrenheit to 350. And the output, the seal strength is much higher, starting at 2 to about 4 pounds per inch seal strength, all the way up to 6 to 8. So with these higher seal strengths and that material type, this material combination is much more suitable for steam sterilization and can withstand the high heat associated with the moisture and the vacuum cycles where the 48 gauge polyester in uncoated 1073B Tyvek cannot. So it's important to understand everything your product's going to see. Steam sterilization isn't as common as ethylene oxide and gamma radiation, but as we explore new modalities, really want to take into consideration what material combination you're using and if it's compatible with what you're trying to use. We have talked a lot about pouches in this presentation, and pouches are very common. We also can consider when it's not appropriate for a device to be in a pouch. Sometimes to lower cost and get something that's already in a system and make it easier, pouches are used. But, getting a tray system and updating that so you could have a three-dimensional type package can help with mitigating the risks that we've talked about earlier. So some things to consider with a thermoform rigid tray, like shown in this picture, this can improve the device protection and lower the risk associated with testing. But obviously, to most of you, it's going to affect material cost. Also, form fill seal type pouches can lower the risk and material cost, but might be a high capital investment. So with these, we want to show that there are other solutions. Right sizing is one way to go, but you also want to consider every type of packaging component and sterile barrier system our industry has to offer. And next, we'll go through another component associated with that, an HDPE backer card.
Yeah, thanks, Jeremy. And the fifth solution is a high-density polyethylene card, a mounting card, pouch card, clean cut card, whatever you prefer to call it. It's an alternative to a classic thermoform tray. So an HDPE card benefits seem to match up very well with what the medical device industry needs for their packaging. So I'm going to go over a few of their benefits here, or what they do. First of all, it protects the sterile barrier from the device itself. So it holds devices still, and it can separate the device from the sterile barrier with features such like a flap. Also, it protects sensitive portions of the device, but just remember that your shelf and shipper should do a bulk of that protection as well. And the best part of the cards is that they're very low profile. So you see the photos, how they're low on the sides. We always design to put the height in the middle, and that way you can bring your pouch, shelf, and shipper nice and tight, but still appropriately fitted. And that runs right into sustainability. So the smaller the package, there's many benefits: sustainability, competitive edge, and cards fit nicely with that.
Thanks, Kevin. And now we'll go to another poll question with Haley.
Great. Thank you both, Jeremy and Kevin. That was a really, really great overview of some defects to consider and solutions to get around those. So our next poll question: have you ever worked with HDPE backer cards? Yes or no? All right, and we're split almost 50-50. So that's a really good baseline to understand. This next portion of the presentation is going to be touching on a lot of misconceptions, some of those that are based around those HDPE cards. So this will be very informative for everyone.
Thanks, Haley. Thanks, everybody, for your participation. That's good to see that we have a split audience. We're going to go through now some common misconceptions, and some of this is going to be focused on cards. So those of you working with them, this might be a review. Those of you new to HDPE cards, this might be some good information to know as you go along in a development process. So the first misconception: HDPE cards are dirty. Kevin, will you start to walk us through this one?
Absolutely. I mean, the answer is no. I think years ago that was a fair question. It was more of a bridge to get from animals to animal studies and eventually into a thermoform tray, and maybe the processes weren't in place. But only if you don't have the right standards, controls, and processes in place could it be dirty. But design is a major part of the project. So designing for proper tooling is very critical. Just because you can prototype it without an issue doesn't mean you should go to tooling, because a bad design will increase the amount of angel hair or stringers present on that card. And these angel hairs and stringers have the potential of breaking off and becoming loose particulate. And also, plastic typically attracts unwanted foreign materials, so converting into clean room is very key, along with a good cleaning process and methods to limit the static. The fact that card's final output is flat allows it to be easily and thoroughly cleaned, which really leads to that cards can be some of the cleanest packaging there is in our industry. Starting with the right materials: if you start a project and you go in with bad material, it's not going to end well. So using 100% virgin high-density polyethylene is a good way to go. There's also other materials that can be used for the right applications. Card manufacturers should have specific tolerances, so a medical device manufacturer knows exactly what they can accept and reject. And the last thing I'd look for is it's always nice to get biocomp testing on the material before you start a project, just to have that added confidence that it's going to go smooth.
Thanks, Kevin. How about the second misconception of medical device packaging? HDPE cards push through seals.
Yeah, historically, I have not seen that, but like stringers, burrs, or angel hairs, designing correctly can help eliminate or ensure that. Never have a single point engaging with the seal. So you see in the top right, you have a chevron shape on the card. And to me, that's a little too much point. I like to round that off a little bit so that as much of the card touches as much of the seal as possible. That way you're dispersing the energy. You never want one point jabbing or going toward that seal. That could end badly. Pouch fit is crucial for this one. I know you talked about it, but I see it all the time. Under or oversizing your pouch can increase seal creep or the chances of seal creep. And it's not just the right pouch fit. Proper fitting of all packaging system components is very vital. So don't sleep on proper sizing the shelf and shipper, because it could affect the overall performance of the card.
And for our third misconception, thicker pouch film is always better. We'll review the Galbo flex testing and flex durability of films as we discussed earlier in this presentation. So if you remember the section with our material review when we talked about puncture resistance, in that situation, it showed that thicker material was better for puncture resistance properties. For Galbo flex testing, thicker pouch material may have a lower flex durability. So that means that it could be more susceptible or more prone to flex cracking when put through the Galbo flex tester. And the Galbo flex testing, for those of you not familiar, is shown in the right side of this slide, where in this test, its film sample, which is 8.5 by 11 inches, is flexed 2,700 times through this fixture. And after this conditioning is performed, the film sample is removed, laid on a piece of white notebook paper, and dye penetration solution is applied to that film, and then removed, and all of the pinholes are counted. So this is much more than a film will see in any kind of real world situation. But this test is used for a ranking mechanism to show differences between thicknesses of film and different types of film and what the resistance to flex cracking is. So the graph on the left is the results of this test for 4 different types of materials. So we tested 48 gauge polyester, 92 gauge polyester, 60 gauge nylon, and 100 gauge nylon. And on the left, the x-axis of this graph are the number of pinholes found after this test was performed. The 48 gauge polyester showed about 40 to 50 pinholes, while the 92 gauge polyester showed anywhere from 75 to 85. So the same material with a thicker layer of polyester showed about twice as many pinholes when increasing that thickness. But on the other side of the graph, on the right side, we show 60 gauge nylon in our test. There was 0 pinholes after this test, and 100 gauge nylon, 3 to 4 pinholes. So while this isn't going to mean that any film is going to show these holes in the real world, this is a ranking system, and it shows that nylon is much more resistant to flex cracking than polyester. But the important message for me in this section of the presentation is that thicker pouch material is not always better. Sometimes we see when a defect can occur that the natural reaction to fix that problem is to go with a thicker film. In some cases, like puncture resistance, that's true. But when it comes to this issue, the Galbo flex and the flex durability, we want to be very careful with that film selection. And typically going with a nylon is going to give you better results than going with a thicker polyester. Kevin, for our 4th misconception, disposal of large packaging systems is difficult.
Yeah, that's definitely a misconception. So one of the best features of cards is how easily the footprint can get smaller. So cards just need to be rigid enough to pass the testing and perform the aseptic transfer. They don't have to be so rigid they can't fold with some applied force. So cards can be broken down or designed to roll up like you see in the photo. And then on the right, you see that it's breaking down. Even though it has the pop and lock or rigid reinforced rails, it still breaks down into a smaller footprint. And that material is or virgin high density polyethylene material that we use is 100% recyclable.
Thanks, Kevin. And next we'll talk a little bit about usability or aseptic presentation. So misconception number 5, optimizing aseptic presentation using pouches is challenging. Well, this can be challenging because if you have multiple devices within a pouch, the handling during aseptic presentation may be challenging, where devices may scatter around the table, fall on the floor. You know, there are a lot of risks associated with opening a package with multiple components inside. So back to HDPE cards, this is a good way to organize and contain devices within a pouch. In this picture on the right, we show a multi-device package in that card through the aseptic presentation process. This also provides protection for the device, but also for the sterile barrier system from the device. And it can cover any sharp edges or anything and keep it contained so the devices are not moving around too much within the pouch during distribution. And that can mitigate a lot of the risks we've discussed here today. Also, a smooth transfer into the sterile field. The cards offer a nice organized fashion of transferring these devices into the sterile field and landing on the table and doing the dump method into the sterile field. It can land nicely on the table on the flat side of the card. This does also help address the usability evaluation that's become a very big trend in our industry because of the update to ISO 11607 Part 1, as well as the guidance of EU MDR. And in 11607 Part 1, specifically Section 7.2 in B and C, this type of design can help address those requirements of the standard. 7.2b is the ability to recognize and perform the technique required to open the sterile barrier system without contaminating or damaging the contents. So using a card in this situation can help lower the risk of contamination by keeping the devices nice and secure, and the damage from dropping too harshly, and the protection of that card could help soften the blow. And then also in 7.2 Part C, the ability to subsequently present the contents aseptically. This is essential to the success of your packaging system, and cards can help with that success.
And this is a video of the septic transfer. So as I mentioned earlier, it just needs to be rigid enough. The rigidness or thermoform-esque look to it is to help the septic transfer and also get by testing. The more rigid a package is, or movement plus some weight, is what causes damage to that sterile barrier. So those rails are very important. So this is just highlighting how you can grab one end of a long card and still get into sterile barrier just fine. Sorry, sterile field, I apologize.
Thanks, Kevin. We have one bonus misconception. Folding pouches is bad.
Yeah, so we do fold pouches. So the heavier the device, the more consideration or more apt we are to go toward that direction. But over the years, I've actually changed that language more to a gentle roll than a fold. You definitely don't want to do a hard fold, crease, or a nice pleat. That would help guide you toward failure. The one thing I want to point out is you would never want to roll the ends and then fold the sides as well, because if you look at the top left, you see that happening. And that's a clear box. It's made out of polyprop just so you can see through, but obviously it is made with an SBS or E-flute material. But that triangle, if you can help me with the mouse, Jeremy, is a point that interacts during testing or real world with that carton. And that is that will cause rub and head toward failure as well. So at the bottom is more of the shape you want to see. It's more of a C shape or a curve or end of a toboggan. And that will help. Actually, what we do is add a little more chevron to tip. Usually it's 3/4 of an inch, but we extend it to about 1.25 inches to get a better shape. And that seems to do a better job getting through the testing properly.
Thanks, Kevin. And that wraps up the misconception section of this presentation. And now Kevin will walk us through a few case studies.
This is a case study. This is a project we did in the past, but first I want to talk about how important collaboration is. You want to have a very deep dive upfront talk about your device and what you're trying to do. So the more we know about the device and how it works and what it does and how is it manufactured, you can even incorporate cards into the manufacturing process to help facilitate it. If you can discuss how it's used in the prep, during, or after, you can start baking in items that will help facilitate this during the surgery. And that's the way you head toward next level or award-winning packaging. So in this case, a customer came with a failure, a card that did not do well. They had 45 days to get back to testing and move forward. We asked them if they had any accessory pieces. It's always good to take accessory pieces or secondary packaging and incorporate it into the primary packaging for many reasons. And then you have ETO is what they were going through. And we want to find out what portions of the device might be sensitive or have coatings, which they did. And the big question was, if you failed this next testing, what happens? And the answer was miss the product launch date. The project could be shut down, and that can't happen. So we decided just to over-engineer just a little bit. And why would we do that? Over-engineer to pass testing. But you got to be careful, because that's always typically at the expense of the end user or usability factor. The more you over-engineer, the harder it is to get the device out of the package. So as this next slide shows what we did, there was multiple issues with the packaging system. And sometimes a customer or MDM will only want to do one or two, but as you fix the multiple issues, it raises the probability of passing that rigorous testing, as Jeremy explained. So we added a flap to have that separation between any rigid parts and the film. We put in rails or reinforced rails to give it that thermoform-esque feel. And we definitely appropriately fitted the pouch size and changed the material to a more robust puncture-proof film. And the last thing is we made sure that the shelf card and shipper interacted with each other properly. Too little room, and it's hard to remove these items. Too much room, and that weight plus movement is what will cause the damage. So in turn, they passed the design verification on the first pass and had a successful commercialization. And this is case study 2, and this is more fun to show how complex or intricate these cards can get with the right data points. This customer wanted to put the device into the sterile field. They wanted to rotate the handle for prepping of the device. They wanted to get to the distal tip so they can do that prep. And so you see here how the card and tube is being removed, and they wanted to lock it into a 45-degree angle to help make that possible. So not all projects will be as complex or intricate as this, but it can be very simple or it can get really complex. That is up to the need of the device and the MDM who's looking for that package.
Thanks, Kevin, for running through those case studies. As we wrap up the content portion of the presentation, we want to leave you with a few key takeaways. First, a pinhole isn't just a pinhole. There are various failure modes that can lead to a breach in the sterile barrier system. Thinking back, we reviewed 6 defects, and 3 of those led to a pinhole. And the message that we want to send is just to look further into the cause of each pinhole that you see. We hope you don't get pinholes during testing, but if you do, it's important to really diagnose what the cause was, because as we reviewed, different solutions should be implemented for different defects or different causes of those defects. So for example, thicker film might be good for puncture resistance if you find a hole that's caused by puncture, but it may not be appropriate for a hole caused by flex cracking. So you really want to be careful with material selection and also the pouch style and pouch size that you're working with. Also, optimizing your packaging system through right sizing, design, and material selection is a key to success. That's a very clear message we hope we got across through this presentation, that Choosing the right size, but also the right packaging configuration and packaging components are essential to success, as well as the right materials for the particular device that you're packaging.
And the last one's HDPE cards can be a fast, cost-effective solution that offers device retention, sterile barrier protection, and end user benefits. It really can organize and present your device nicely.
Great. Thank you, Jeremy and Kevin, for a wonderful presentation. We will now move on to the Q&A section. So as a reminder, you can use the Q&A function for this and not the chat box, please. So we'll go ahead and get started. Kevin, this first question is for you. For our cards, a couple of questions. The first is, are there other materials besides HDPE that you see being used, and what might that be for? And along those same lines, within the family of materials that could be used for cards, are there any that use recycled content, or is everything really virgin?
Yeah, so I've tried many materials to see what works best. The other material that we'll use for autoclave applications is polypropylene, and it's really design dependent if it makes it through or properly does its job. On the question about virgin high density polyethylene, at this time we're using only virgin grade because regrind, there's a risk to using regrind. That doesn't mean we're not actively researching to try and overcome this issue, but that is something we're trying to research and get to.
Okay, great. Thank you. And Jeremy, for you, is there a difference between thicker PET or nylon in terms of where you see more pinholes during distribution testing?
Yeah, so there's different parts of the distribution test, and mainly for this conversation, we can focus on drop testing and vibration testing. And, as we discussed through this presentation, the vibration cycle, the main risks associated with that are flex cracking and abrasion. And with flex cracking, as we talked about, nylon does offer more resistance to flex cracking than polyester, and thicker in that sense may lead to more pinholes, while abrasion, the scratching of the pouch material against a device or the shipping container, that can actually cause a different type of defect. And so in that case, a thicker pouch material might be better. So it's a very good question. It's going to be case by case. Generally speaking, nylon is going to give you more protection than polyester, but also add cost. But really, you want to pay attention to the thickness. If you go with 100 gauge nylon for everything, you may run into flex cracking after distribution, where a 60 gauge nylon might be a better solution. However, 100 gauge nylon in most situations are going to get you to success, but you need to work with your project team around cost and consider all the risks associated and properly design the packaging system.
Great. Thanks, Jeremy. All right, Kevin, when it comes to folding pouches or rolling pouches, as you better defined, have you seen examples where maybe stacking products on top of each other could cause that roll to become a sharp fold and then cause problems?
You want to orientate it in the shelf and shipper properly, and you want to make sure you go film to film with the device in the middle of it. But the issue that anything can happen in the real world or through transportation, but the other side is leaving it flat on a 72-inch heavy device will create unwanted wrinkles and folds in a way you can't control. So no, I don't see many issues with it. It is a gentle roll, but the other side is a lot worse in my experience.
Yeah, and in addition, I can add to that, Kevin. I mean, you could be planning for rolling. So if you have a shelf carton and then you have a pouch within there and you want to gently roll the end of your pouch, if you're not right sizing your carton, maybe it's too small or too big. Either way could cause issues where there could be dynamic forces within that could actually cause it to double fold or compound fold, even though you're planning on rolling. So again, design is very important for this, plus manufacturing, to roll the end, but also design your packaging system so no other unintended defects occur. with when the device is inside the packaging system.
Great, thank you both. Okay, next question. We've had a couple people bring up trends in double versus single sterile barrier systems. So are you seeing trends in using one or the other? And does one seem to work better than the other? Does the product matter?
Kevin, I can start there and like to hear your thoughts too. But in my experience with double versus single, it's really application and product specific. You know, I'm not familiar with any regulations that guide this. You know, we've talked about that in the past where some people thought, you know, sometimes doing double sterile barrier is required because it offers more protection or more sterile barrier integrity or sterile barrier protection, microbial barrier. But really, if you have one system, because especially if you're using Tyvek with the film or a tray system with a Tyvek lid, that will really offer the same type of microbial barrier as a double sterile barrier system would. So there's not much difference in protection. What I've heard with trends and the difference between the two are user preference. So maybe based on cost, and I know I saw a question about orthopedic implants. Those are high cost and they are high classification. So you may want to add more material, add more sterile barrier for risk mitigation. But also with in the end user in the sterile field, there may be times where the outer package, the first sterile barrier would be opened. And then in the procedure, they ended up not needing to use that inner barrier. So that way they can reuse that pouch, put it on the shelf in a safe manner, and maybe have the opportunity to reuse it. So sometimes it's the preference of the end user more so than a protection or a sterile barrier requirement. Kevin, do you have anything to add on that?
Yeah, I have a few. A majority of the products that we work on, I've done thousands over the years, are single barrier. There are always certain areas of medical that stay with the double barrier system, such as neuromodulation, is what I've noticed. The only thing I would say is that I encourage single barrier if possible, because from a packaging design standpoint, because it creates less movement. When you have that double pouch in the shelf card and you're matching the width of the shelf card with that outer pouch, that double barrier causes more room for that device if it's heavy to roam. So it just could cause a little more damage, what I've seen, due to that extra space.
Great, thank you both. All right, next question. So Galboflex results can change quite dramatically after sterilization and aging. And I think the same rings true for other characteristics of a package config and its materials. So Jeremy, does Oliver do anything during material development to check for this?
We have the capabilities. So looking at this question holistically, it's accurate. Some materials can be affected by sterilization, especially irradiation like gamma. For example, nylon based film laminations can become a little bit more brittle, more stiff and brittle during high amounts of exposure of radiation. So typically what we've seen with our studies is that not much with material attributes are changing through the typical 25 to 45 or 25 to 50 kilogray exposure. But if you're doing a double cycle and it gets up to, you know, from 80 to 100 kilogray or above, that's when the changes may start to occur that you would notice in your testing. So we do have the capability. Generally speaking, we're not doing that on a regular basis because most of the products really aren't affected by that standard range. But if your organization has a particular specific dosage of irradiation you want us to look at, we have the capabilities to do so.
Great, thanks. So Kevin, a couple of questions about cards here. The first is, what are some of the thicknesses that we use for our HDPE cards? And I would add on to that, are there some that are more common than others? And then the second question is, what sort of inks do we use on cards? Is it water-based ink, UV digital, something else?
So first on the material thickness, we have in thou, 14 thou, 23, 28, and 35. I'd say predominantly we're using 28 thou for most cards, but when they get over several feet, you kind of gravitate toward 35 thou. but you keep straps and different added items at that 28 thou, so they conform around the device a little bit better than 35 thou would do. So on inks, there's several different processes that we use. There's pad print, there is screen print, there is offset print for more complex art, and there's different inks depending on the application that we would use.
Great, thanks. All right, next question, Jeremy. I think this will go to you. Is the same adhesive used for all material combinations?
No, the adhesives for, and when we talk about adhesives, I suppose we can talk about between in that the adhesives or the seal of a pouch, let's say, for example, or even a tray. But for this, let's talk about pouches. So the way that a seal is formed can be done in multiple ways. So the Tyvek in the situation we talked about today was mainly uncoated. And then the other side of the film can have a sealant layer on there. So when we say adhesive, the mechanism for making the seal might be polymer-based adhesive that's coated onto the Tyvek, but it can also be a seal layer on the film side of the pouch. So low density polyethylene is a very common sealant layer, but also there's co-extruded EVA based sealant layers that offer that peelability. But you can also, and more directed towards an adhesive, at Oliver, we do apply adhesives to the Tyvek on some pouches, but also on most of our Tyvek lids, because that adhesive does offer that ability to seal to rigid trays. And in that sense, we offer up to 50 different types of adhesives for Tyvek and medical-based paper, but they all have similar functionality and similar performance and formulations, but they do have differences. So the question, generally speaking, adhesives, there are a lot of nuances and differences, but generally we can look at the same because they're all making a seal in the long run, and we're all looking for that integrity and that strength.
Great, thank you. And back over to you, Kevin. Are there typical dimensions that you recommend for sizing a pouch based off of a backer card? For example, do you typically add maybe a 1/4 inch in certain directions or certain dimensions, or is it really very different depending on your end device?
It is very different depending on the end device. The higher the profile, I can tell you, the harder it is to match up a perfect pouch, because as you get to 5, 6, 7, 8 inches high, you want to have a natural look to your pouch, but yet then it's getting wider and wider. So I couldn't tell you exactly a formula for it, but we fit each one with a physical pouch over the device to make sure we get the right look that we want to make sure it has its best chances of going through testing.
Okay. And then another one related to designing a shelf or shipper cartons. If you're rolling a pouch, is there a certain amount of excess headspace that you add to a carton to prevent that roll from becoming a fold?
I would say that no, we don't add extra space. You want to limit, you want the shelf carton nice and tight, but without causing those compound folds. So no, that's not part of the equation. If we have a 1 inch high device, we'll have that shelf carton just 1/8 of an inch higher, and so it gets that C shape that we're looking for. But no, we're not trying to increase space to keep that giant C shape. We're trying to make sure that it only moves left to right in the shelf carton, and that up and down or north and south is really limited on movement.
Okay, got it. Thank you. A couple questions here related to the use of Tyvek. Jeremy or Kevin, are you seeing anyone trying to use other porous materials besides Tyvek? Or in the case of maybe using a double pouch, do you see someone maybe trying to use something other than Tyvek on that inner pouch?
Yeah, there's a lot of conversation, seems, in industry right now around Tyvek, and my comment for that is that the properties and the protection and the attributes of Tyvek really are unmatched for a porous material. So there are developments out there. There's always people looking at Tyvek alternatives. We do, and the industry does have medical paper as an option and reinforcements inside that paper that offer similar attributes, but ultimately Tyvek 1073B especially is the highest amount of protection that we see. And those alternates out there, we're always looking at to see what's the new technology, but as of right now, Tyvek really is still the most common material we're recommending for porous materials. Depending on application, we can recommend paper, and alternatives also can be film to film, whether if you have an ETO sterilization or a gamma radiation or any type of radiation that doesn't need porosity, you can consider that film to film style pouch.
Great, thanks. And this is an interesting one for maybe either of you. So when you're running seal and peel tests on a pouch, it's usually without anything inside that pouch. Is there any difference or benefit to adding a card into that scenario when you're doing that seal and peel test?
Jeremy, if you want to field that.
Well, I mean, I don't know if I'm going to be able to answer the question directly, but adding a card, as we talked about within this presentation, does offer a lot of attributes and a lot of protection and a lot of properties to a pouch packaging system, as opposed to a pouch without a card. So the seal strength really isn't necessarily going to change, but you can avoid things like seal creep. You can avoid any other, things that might happen with a device floating around within a pouch, because the card does maintain a little bit of security for a device, so your seals aren't as affected. So the answer, I believe, is yes, adding a card can protect your seal and offer less defects and less risk to your seal area.
Great, thanks. I think we've got time for one more question here. So back over to you, Kevin. We've got one participant who mentioned that their experience with HDPE backer cards has attracted foreign materials like loose fibers. So does Oliver do anything to reduce the presence of foreign materials on their HDPE backer cards?
Yes, definitely. That's a daily fight because of, like I said earlier in the slides, that plastic attracts foreign particulate. But yes, ionized air systems that we use in multiple points is what helps limit that static that attracts.
Great, thank you. And thank you everyone for your participation in today's webinar. If we didn't get to your question, we do apologize, but we will be fielding them and following up with responses after the webinar. To stay up to date on the latest news, innovations, and trends in healthcare, check out Pack Talk, a blog written by experts for experts. Have a nice day, and thanks again.